Copy these definitions of these terms so that you have them. These are old terms. Average rate of change is just the slope of a line that connects two different points, and the system of three linear equations. So you'll need those in order to proceed on to this section. Similar to writing linear equations, whenever we're given certain pieces of information, we need to know how to write the equation that models that data. So depending on what we have will determine which form we use. So if we've been given a point and a vertex, we're going to use the vertex form. Kind of makes sense. If we've been given a point and the x-intercepts, then we're going to use the intercept form. Of course, P and Q are just the labels that we give them. And then if we've been given 3 points, then we're going to write and solve a system of 3 equations and 3 unknowns. Okay, so that's what we're getting ready to do. So let's get to it. The easiest way to do that is to just go through some examples. So we're going to use the examples in your student journal to make it easier on you. So in this particular graph, we have the vertex of 2, -2, and we also have a point of 4, 6. Okay, so when we think about vertex and we have a point, we should be thinking vertex form. So let's just write that out just so that we have it for ourselves. We have y equals a times x minus h, quantity squared, plus k. Now our vertex is of the form h, comma k. And so we can take our h and substitute it into our equation. So that's the 2 going in there. So we have y equals a times x minus 2 squared plus our k, which is a -2. Okay, so we have that stuff figured out, but we don't know what our a is. Well, to figure out what our a is, that's where we use our point. Because now if we substitute this point in for our x and our y, well, the only variable we'll have left is our a. So that's what we're going to do. When we rewrite this, you'll notice that the items in blue are the point up here. So I changed the x to 4 and the y to 6. And the items in red are the h and the k, so the 2 and the -2. So now I can just do the math here. So very quickly, 2 squared, of course we get 2 from 4 minus 2. 2 squared is 4. We add 2 to both sides to get rid of this -2, so we get 8 over here equals 4a, but we need the a to be by itself, so we're going to divide by 4, so a equals 2. So that was the only thing that was missing up here was our 2, and so now we can just write our equation. And if you recall, if we start from our vertex and we modify our x by 1, our y would be modified by 1, but in this case it's modified by 2. So that means we must have multiplied the y by 2, which is exactly what we're experiencing. If we modify the x by 2, the y would be modified by 4. But instead, it's been modified by 8, which is just 4 times 2. So we've confirmed that we've got that right. Looking at problem 2, we have the same thing. We have a vertex and a point on the parabola. So see if you can figure it out. So pause the video, work it out, and then resume to see the answer. Three and 4 are similar problems. It's now they've given us the information. We don't have to take it off of a graph. So the vertex is at -1, -8 for number 3, and it passes through the point -3, 0. So you solve it the same way. Number 4, it solves the same way because you've been given a point and the vertex. So you're going to use vertex form, and substitute all that information in. The only thing that you don't know is A, which is what you're calculating, and then you can go back to your basic form and substitute those values in. So that's been left up to you. I will look at your answers when I collect your student journal at the time of the test. Equation 5 tells us, or problem 5, excuse me, tells us that we have to write the equation in intercept form. So we need to recall what that is. So y equals a times the quantity x minus p times the quantity x minus q, where p and q are the 2 points that lie on the x-axis, the x values of those points. So we can tell right away that we have a p value over here and we have a q value over there, and we have another point on our graph right up here. Using all this data, we can substitute it into our intercept form equation, because the only thing that we don't know right now is A. So once we substitute it in, we will be able to find A. So let's just go ahead and do that. So once we've substituted all those values in, the only variable left is this A. So we're just going to do our math and figure out what A is. And then we can substitute our P back up here, our Q back up here, and then we'll have our A, which will give us our equation in intercept form. We now have our equation once we've solved everything for A equals -1. So we have our negative x minus our p is -4, so minus a negative gives us a +4, and then x minus 6. Problem 6 is left for you to resolve, and once you do, you can resume the video and you'll see the answer. So try it on your own and then look at the answer. Here's the answer. Problems 7 and 8 are very similar to what we just did. So again, those will be left for you to complete on your own, and I will look at the answers when you turn the student journal in at test time. This is the last portion of this section, and this you will see goes back to when we were doing linear equations and we kept doing the slope is delta y divided by delta x. Well, we're going to do the same thing here, and recall when we were looking at delta y divided by delta x, we were trying to see if things were linear and to find our slope. Well, now if it doesn't turn out to be linear, we need to see if it's quadratic. So you'll notice that in a parabola, because it's curved, it doesn't have a constant slope along the graph, but there is a constant rate of change, and we'll see that as we go through these. So let's first do what we've done in the past. So we'll notice that the difference to go from 1 to 2 is 1, 2 to 3 is 1, 3 to 4 is 1, 4 to 5 is 1, 5 to 6 is 1. Okay? But now when we go from 424 to 416, that's going to be 8. When we go from 416 to 376, that's 40. When we go from 376 to 304, that's 72. When we go from 304 to 200, that's 104. Now, of course, I should be putting negative signs on all of those, sorry. And then when we go from 200 to 64, that's negative 136. Okay, so those are not consistent. However, to see if it's quadratic, we want to see if the rate of change from that level, we need to recognize that since everything else is changing by a negative, that 8 would also be a negative. I forgot to put that in there. So when we go from -8 to -40, we've changed by -32. To go from -40 to -72, we've changed by -32. To go from -72 to -104, we've changed by -32. And then the last, we've also changed by -32. So since this is a consistent rate of change on the second level, then we know that this is quadratic. On the first level, if we had had the same rate of change, it would have been linear. On the second level, it's quadratic. So now we can use this information to write a quadratic equation. Before we do that, though, let's practice on this problem. So we have this table of information, and we're going to do our same thing, delta y divided by delta x. So we want to see what the rate of change is. So going from 0 to 3, we have 3. Going from 3 to 6, we have 3. 6 to 9, we have 3. 9 to 12, we have 3. And 12 to 15, it's 3. Going from 36 to 30, we have -6. 30 to 24, we have -6. 24 to 18, we have -6. 18 to 12, it's -6. And 12 to 6, it's -6. Since the rate of change is the same on the first level, this one's going to be linear. On number 11, we can do the same thing. We don't have to do the x's because we can see that they're all incrementing by 1. But on the y's, we have a change of 10, then a change of 30, then a change of 90, then a change of 270, then a change of 810. So now that we know that, we can look to see if these changes are the same. So here we have a change of 20. Here we have a change of 60. So there's really no need for us to go on any further because we see that there's not a consistent rate of change. So it's not linear and it's not quadratic. We'll talk about what it is later, but I just wanted to have you understand that we're just looking for the rates of change. So if they had been consistent at the first level, it'd be linear. Consistent at the second level, it would be quadratic. Problem 12 can be done in class and because we need a graphing calculator. So that's what we'll do with this problem.